What up, guys? Welcome to part two of the video. In this video, we're gonna actually go ahead and start solving binaries. Um, so before we do, we have to clarify a few things between decimal numbers and binaries. So first off, we're gonna figure out the bases that are in the decimals. The amount of bases that you can use before you have to increment the place value of a decimal. So first, what I'm talking about is you got 0, you got 1, you got 2, 3, 4, 5, 6, 7, 8, 9, and then this place is open. Okay, this is where you increment by like another place value. So here you could like write 1 and 0, and you got a ones place, and then you got a tens place. Okay, all right. So in a decimal form, you can count about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bases before you have to increment. And in a binary form, you can only count from 1 to 2. Like, all right, so, all right. If a computer were to count like something, all right, so like let's just use my name for example. So when you look at my name, if you want to count like how many letters are in my name, you're actually gonna like start here saying 1, 2, 3, 4, 5. For a computer, this one is not 1. This one is actually 0, and then 1, 2, 3, 4. But technically they are like 5. Like each of, I don't know, this is 5, and this is also 5. Technically, when you think about it, because the 0, it counts as 1, and then the 0 counts as 2, 3, 4, 5. You got a point, right? But that's just something I want to talk about. It relates to like if you were when we start dealing with like text and like sometimes we might have to like split the numbers. I mean the letters up in data and all that stuff. All right, let's not get off track. All right, so what was I talking about? I was talking about zeros and ones. All right, so you go from 0, you go to 1, and before you can increment. But in the binary, like I said earlier, you either have 1 of something or you have 0 of it. So in order for you to get to this place, you will have to increment. That means you're gonna have 2 here, for example, but you cannot represent it as 2. Instead, you have to like represent it as 1 plus 1, right? But instead of having 2 there, you have to like put 0 here, and then you have to move the 1 over. Like you have to move the 1 over to bring it down here. And that's how you represent 2 in binary. All right, so all right, so let's talk about the place values now. Let's talk about the place values. So this is for decimal. The place value for this is ones, and this is tens, and ones, tens, hundreds, thousand. You got it, 10,000, and so on. Okay. For binary, the place value. You got we actually need this one because we're gonna have to use it to solve problems. The place value for binary starts with 1. Yeah, that's the ones place. And then to go from one level to another, you have to multiply by 2. Okay. So here, for decimals, you start at 1. Yeah, ones. And then to move from there to go here, you get tens. And then to move from there, you go here, you get 100. So you multiply by 10 each time you cross, you go to the left on the place value listing stuff. So for binary, you go from 1, you go to 2, and you go to 4, and then you go to 8, and you go to 16, and you go to 32, and then you go to 64, and then you go to 128, and so on. Okay. It's important for you to like notice because my perspective, right? The way I see this is the value that is stored in this variable. Okay, so y is the variable, and let's just say variable is just like a storage. Let me spell this out quickly. And then this is the value that is in the storage. Okay. So to represent variables, we're going to start here. Say 2 to the power of 0 is equal to 1, and then 2 to the power of 2. I mean, 2 to the power of 1. Oh my God. And then 2 to the power of 2. And then 3 is going to be power of 3, 3 to 4. And then 5, you get a point. Whoa. And then 6. And then 7. Okay, you got a point. All right, so that's it. Now we got the variables. These are here, and then on top of it, we got the values. So how can we use this to solve binaries? I'm gonna go ahead and erase these. All right. So to solve, let's start by simplifying the number 5. Okay. So what if we were to add numbers up to get to 5? What were we gonna pick? Like, what can we pick? So in order to do this, we have to look at the values at the x, and we can see that we got 1, 2, 4, and we can like manipulate these numbers to get to 5. But what if we were to do something like 3, 3, and then let's say 3 plus 2, for example? Why would this be wrong? This would be wrong because 3 is now a value for the variables that comes in a binary. Okay, so 3 will automatically be wrong because when 2 goes into it, there's gonna be like a remainder and stuff. Okay, so that's why you can use 3. And we talked about having none of something and having one of something. So in order to represent 5, you can only pick a single value from the x, and the values that you don't pick, you can only pick a single value from the x. I'm just messing around here. And the values you don't pick are automatically represented by 0. So the values you use are represented by 1, and the value you don't use are represented by 0. And okay, So 5. First, you pick the number from the x to represent that. So we can use 4 plus 1, because those are values that adds up to 5. And then we know that we have 1 1. We have 1 1. Just watch this, okay? We got 1 1 and we have 1 4. Okay, and we have none of the other numbers. So to represent this now in binary, we can go first ones, twos, fours, eights, 16. These are the place values. So in the ones place, we got a 1 because we are using that 1. And then in the twos place, we got a 0 because we're not using 2 to solve. As you can see up here, we're not using 2. And in the fours place, we got 1. Okay, that's how you represent 4 in binary. So that's how you represent 5 in binary. Okay, so what happens? Like, you'll be wondering, like, what happens to these place values? Like, basically, to not like confuse people, all you have to do is use b. So it's b101, and then just put a 0 right here. B, technically, we can just refer to it as like the decimal point for the binary. So you know how let me take your attention this way. You know what, when you have a whole number, you automatically have like a decimal point right here, and with an infinite 0 going that way. For binary, when you have that B, it means that on the other side you have like an infinite amount of zeros going. Okay. All right, so let's make sure this is correct. We're gonna go and ask our teacher, the most ultimate teachers of all, legendary history, king of all king in teaching. All right, let's see. Let's say Google, my dude. 5 in binary form. And Google said this is the answer. I'm gonna copy this. Can I paste it here? No. All right, I'm gonna paste it up here. Whoa, whoa, whoa. Don't reload. Don't do anything. All right, so as you can see, that's the right answer. 0B101. 0B101. So that's how you solve it. All right, so let's break this down in steps, okay? Let's break this down in steps. And you can also use this to multiply. I'm gonna go ahead and start trashing this entire thing. Actually, let's reload this page. It's gonna be much faster. Okay, so first you have the x values. Let's end up starting from 1 times 2 times 2 times 2 times 2 times 2 times 2 that's inverse. All right, I'm gonna stop there, and then you got your y values, your y variables. This basically you got 0 1 2 3 4 5 6 7, you know, like that. My numbers are distorted, but whatever. So now let's use it to let's break the steps down. If you were to solve for a binary number, like to simplify a binary number, simplify another number into binary, or convert another number into binary. That would be better. So 10, for example, first you have to find the x values that can go into 10, that can add up to 10. So we cannot use 5 because it's not in the x area. We cannot use 3, and like pretty much we can use odd numbers, okay? Apart from like I don't know, 1. All right, so let's go. We can use 8, and then we can use 2. 8 plus 2, that's 10. And we know we got 1, 2, okay? So in the 2's place, we're gonna have a 1, and then in the 8's place, we're gonna have a 0. We're gonna have a 1. So how can we represent that over here? You're gonna come here, you're gonna start from 8, you're gonna have a 1, then you go down to the 4's, you're gonna have a 0 because you're not using a 4, and then you're gonna go down to the 2, you're using a 2, so you're gonna have a 1 there, and you're gonna go back to the 1's place, and you're not using 1, so you can use 0. So you either have 1 of something or you have none of it. 1 of 2 or none of 1. 1 of 8 or none of 4. And that's how you solve this. All right, let's check this out. Let's see 8 in whoa, that's not 8 we're solving. We're solving for 10 in binary. 10 in binary is OB1010. Okay, so let's go back. We could put B right here, and just for this one place, representation stuff. We got 1, we got O, we got 1, we got O. Now if you were to multiply in binary, it's pretty simple, okay? First, you got 2 options. Actually, you got more options in that. First, you could just do it regularly. So 12, for example, you could represent it by 4 times 3. Or if you want to like freak everybody out, you can start by simplifying this into binary first. So 4 is represented in binary. That means we'll be using 1, 4, and we'll be using 0, 2, and we'll be using 0, 1. That's 4 in binary, okay? Let's check it out. I like evidence, so that's why I keep like taking you guys to check this out. So 4 in binary is 100, okay? So let's just put an OB here just because, you know. Okay, let it be right there. We're not using this. So we got 100, and we can represent 3 as using 1, 3, and then no, we cannot represent 3 in a binary, but we can simplify it to 2 plus 1. So 3 can be represented as 2 plus 1, and 2 can be represented as 1 and 0, and 1 can be represented as 1. Okay, so if we were to add these two up, we're going to have 1, 1. And then we are using that to multiply by 4. Let's make this a less complex. Control Shift. Well, never mind. All right, so write this out. 4 times 3. Let's check this out. If that's 3 in binary. 3 in binary is 1, 1. Okay, so that's perfect. Let's go here. We can do, so 2 is, and then 1 is just 1. All right, so multiply, we got 0. We just uh, got 0, we got 1. We got 0. Whoa, whoa, I can't even write there. 0 and then 0 and then 1. And we can represent that as 1, 1, 0, 0. So let's check this out. If that's actually 12 in binary. So 12 in binary, as you can see, is 1100, and what we got here is 1100. So it's pretty easy. Yeah, that's how you do it. And if you were to divide, you could I don't know. It's the same thing, you know. You can like first you can do it you can do it regularly, or you can like make it. You can be extra with it and just convert everything to the binaries and solve. But it's very simple. Like once you know the basis. So thanks for watching. The rest of my videos coming up will be about a little bit more about hardware and about computer and processors. We'll learn about the type of memories and what they do and stuff. And then we're gonna dive into .NET, learning about the frameworks, and then we're gonna start using a .NET scripting language, which I'm pretty much familiar with. I've been using it for about 5 years now, and we're gonna be designing stuff. First, we're gonna write a console application, and then we're gonna go into full 3D, and then we're gonna build a 3D game, and it's gonna be pretty cool. Uh, yeah, so that's just a little information about what's gonna show up in the future. Thanks for watching, and I'll see you when I see you. Bye bye. Bye bye. Bye. Bye bye. Bye bye.